Thanks for having me here. Super excited. I'm the PM lead for Azure Functions. Work Microsoft on the product team based in Seattle. And one thing we do on the team, me and the rest of the PMs there, is we talk to customers all the time, and we do this thing which is pretty interesting. We go to customers that are not really sure about serverless, and we visit them, and they have a problem they want to solve, but they don't know where to start. So we do those things called hackfests, where we sit with them for 3 to 5 days, and at the end of that week, they come up with something that's serverless, and later on, they move it to production. So in those trips we've done, we've learned a few things I want to share with you today. I picked 3 of my favorite customer cases to share with you to see how we're changing the product. But before I get started, actually super excited to be here because, you know, Israel, Tel Aviv, cutting edge technology. And when I signed up for this, what I didn't know is that this place is going to look like my hometown. This is where I'm actually from. It's called Recife, which stands for coral reef. So it makes these nice little natural pools there, okay? So if you don't learn anything serverless now, you learn at least one word. All right. Here are the 3 customers I'm gonna talk about their use cases, and they're very, very different. The first one is IoT and machine learning, which is pitched a lot at Microsoft, other places, and IoT always seems super sexy, not always tangible, so I'm gonna get a very tangible case here. Fujifilm, how they went to the cloud straight into serverless. Not always I advise that, but they had good success. And another company that had long-running functions. So let me get started. So Fagor Ederlan is a company in Spain. They manufacture auto parts, and auto industry is very costly to manufacture parts that have to be recalled, as you would imagine. So precision on those parts is super critical. So they're old-style IoT company before IoT was called IoT. So they have mechanical arms that manufacture parts, and that goes into a molding machine. That has proprietary software that talks directly to some sort of really old version of Windows that can't be touched and picks all these 3D measurements of every single part and saves them as a bunch of CSV files. So it's a little messy, right? And what they wanted to do is, instead of having a quality assurance person that inspects parts to find out when they have defects, they want to have machine learning model to detect that automatically. Makes a lot of sense, cuts a lot of costs, improves the quality of the product. And they want to do that in the cloud. And here's how they did it with serverless. And I'll go over a few serverless concepts here. So the first one is they pushed their data that was local to the cloud. And in Azure, we have IoT Hub, which is part of our messaging set of products. It's very good for really burst events. IoT typically is about tons of events being sent. And every time a set of those CSV files was sent to the cloud, those files would get uploaded to storage. And a function, which is the product I'm part of, I forgot to introduce the icon, actually reminds of the Power Rangers icon. I hear that's not an accident, was one of the PMs that designed it, but I derailed. So the first function, what it does is every time a set of those measurement files is uploaded to Blob, it triggers a function. That's the event that causes the function to run. That function picks those files up, but uncompress them and put them in some other storage, which has another function that will listen to it and will make that data in a structured format that looks more like a table. One interesting pattern to know here that you can apply is typically any project involves serverless involves tons of functions. Like rarely we see a project that's a single function. You want them really modular. In that case, they had 2. Once they write to that table, they can run that inference against a machine learning model to judge whether a part's defective or not. The results go into a Power BI dashboard on your right, and the quality assurance person, all they have to do is monitor that dashboard to know if a machine needs maintenance or if there's something wrong with a particular part that has to be acted upon. So that's pretty cool because they were able to add ML that way. One part I really like that's more typically more complex about machine learning, let me do this again. It's number 3. Not only they did the inference part of machine learning, they also did the retraining pipeline. They make the machine learning models better with every measurement. The way they did it is for every single one of those defective measurements, they sent it back to the system to be collected with the historical data. They use Hadoop, and they retrain the model. They have a little, it's a supervised machine learning model, if you're familiar. So there's a little interface that an actual human goes through to input whether parts are effective. And now the model knows all these new cases and keeps evolving over time. So, and they did all of that using different things with functions. What we've learned in this case is a few things, and for every single one of these cases, I'll go through what we've learned. One is, if you want to have a serverless app, compute's a big part of it, and I'm part of the Azure Functions team, but you also need to have your event infrastructure that's really scalable. In Azure, we have a bunch of them, IoT Hubs one, Stream Analytics, Event Hub, etc. You also need to have your data in a format that's also serverless. So you don't have to worry about how much you're provisioning. It can grow elastically. So blob, table storage in Azure are good ones. Machine learning, a lot of times, sounds complicated. What I've learned personally, I worked in Bing. Bing is a search engine, not Google. A lot of machine learning processing data is like filling in details missing on the data, removing duplicates and things like that. So a lot of discrete process happening in machine learning. So serverless can be perfect for those data preparation process with atomic functions. And with IoT, the other thing we learned is, in this example, all the IoT events are processed in the cloud. That can be really expensive. There's tons of data that you're sending from local to the cloud. So as much as possible, you want to do the processing locally. So in Azure, we have a product called IoT Edge. The same function that you run, that you code and runs in the cloud, can also run locally. So it's the same exact model. But you want them processed locally because now you don't send as much data to the cloud. And connectivity, a lot of times, is an issue. So that's the first case. Second case I want to talk about is Fujifilm. You guys probably all know Fujifilm from digital photography and the products that they offer. But they also have a very successful business selling software to manage images to corporations, a business-to-business project. And this was built, as the UI shows, over 10 years ago, but sells really well for Fujifilm, especially in Japan, because that's their market. What was happening, though, is their first venture into the cloud was in their own, it's not really the cloud, it was their own data center. So the way they sold this software was to companies, but they all would access the Fujifilm data center in Japan. And as they were getting more parallel requests, they couldn't handle that scale. And the scale was very bursty, so they'll have a lot of load and then no load at all, so they didn't have a good way to provision machines and things like that. Also, they're running out of storage space. So it's natural for them to go to the public cloud. The original system was all built in Java and used Postgres as a database. And then they started to go to Azure. We're using Cosmos DB, which is our elastic global distributed data product that's also serverless, and Azure Functions. And the way they did, I know there's a lot here, so I'll cover a few things. That little interface they've seen, that little UI, it's actually a web app, which is a platform as a service, not serverless product. Those are allocated servers to run your web application. So every time you upload a file on that app, it goes through this path here. And they broke it down into multiple serverless solutions. So every time you upload an image, what it does is the image goes to storage. The storage enter an event on a queue that will trigger a function. That function ensures data consistency. This layer here is on the data center, and the old system and the new system both record data here. So if you use the new cloud system or the old one, they all be in sync with those databases. So that's what this set of functions does. The other set of functions is every time an image is uploaded, it runs through machine learning. So it can do OCR, detect properties on the images, do automatic categorization of those images. Now, every time the old or new system adds something, another function also has an event that will ensure to update Cosmos DB. That's where the keyword terms are for searching. So if you search for an image, you could find them. The meta point here that we learned with Fujifilm is every single solution that you have, there's several components, and you need to find which ones of them you can organize into serverless solutions that you can use. They built all these parts with serverless, and they used some non-serverless components like web apps, and that was very successful for them. I think their first proof of concept was 1 to 2 months for them to put something like this together. Where in the past, the Java team that built the original app would take them way longer just to add features, let alone build a whole new application. So in this one, I talked about breaking down the functionality if you want to move into serverless, into distinct modules. The other thing, if you're a developer, you need to become very familiar when you're doing this distributed async computation with queues, so you can chain multiple functions, multiple processing together, and async await calls, because you want everything that you do by nature to be asynchronous, so they can scale parallelly. And the last thing I like saying, although Azure Functions is mostly serverless, 3/4 of my customers are using Azure Functions in the serverless way. They can also use it in dedicated fashion. And sometimes dedicated resources is better. Like if you, in this case, you have really high HTTP throughput, and it's a predictable workload, not a bursty workload. Sometimes you want a web server that's there, ready to respond at all times. So as much as I would like to say always go serverless, is not always the case. Some things are better with just dedicated resources. And here's the last one that I have. It's actually a company from Brazil. They do payment collection, not the kind that you beat people up, but the kind that you notify over text message or email. So they make sure they sell it to banks, financial institutions, so they can get paid. The way they do this, they have a pretty sophisticated algorithm that's effective on letting you know that you have some payment due. So what they do is first they send you a text message to say, hey, your payment due is today, here's how much you owe, click here to pay. If you don't respond to that, they send another text message, probably more alarming. If that doesn't work, they go to an email channel. If that doesn't work, they send you some printout for you to collection that you can pay at home. If that doesn't work, they do automated calls. So they have a whole escalation engine for you to get your payments done. And they're a software company and they sell that. What's hard here to do it with serverless is this whole process of collecting payments, they can last like days, sometimes weeks, until they can pre-process. And functions by nature are short-lived processing parts. So we have this concept in Azure, it's called durable functions, where you can write an orchestrator function. That orchestrator function can live virtually forever, and they can call into other regular functions, which are your short-lived. In the case of Azure, the functions can run up to 10 minutes. And this is not their actual logic, because that's their IP. So I kind of replicated one logic that you could implement. And what they do is with the orchestrator function, they read data from Cosmos DB, and they can decide if you haven't paid yet, send a text message with one function. And if you still haven't paid after 24 hours, send another text message. If you haven't paid 24 hours, go by again, then you send an email, and finally you send boleto, which is a Brazilian method of payment, which is a printout that has a barcode, and you can print in a lottery house or over an app on your phone. And once you pay, you send an email. So I kind of implemented that the last few days just to show some of the simple code to you guys, because that's something that's super simple to achieve, and it was very successful for Direct One. So it would look somewhat like this. And this is the actual function. I just my own sample code because I can't show the Direct One's code. But the two things that you have worth calling out here is the orchestrator function. It's a regular method here, and this is C#. You have an attribute to indicate function name, an orchestration trigger that indicates that this is an orchestrator function. So that's the one that can run forever. The other thing that's special here is I create a timer. I create a timer for 1 day, and then I call into another function, okay, which is here. So this is the name of another function that I have on my code, which is what I'm going to show next. So if you do these 2 parts on your orchestrator function, you'll be able to chain tons of logic into this orchestrator. Here what I do is I create a timer, I call into this function, and then I wait either for the payment to happen, check for any event the payment happened, or for the timeout to expire. And what's cool about this is the orchestrator function, you only really pay for that function when the code's running. All the await time you're not paying for. So it's still as cost effective as regular functions, but can run much longer. And the actual function has an attribute that indicates the function name, and the only thing really special here is the activity trigger. Activity trigger indicates that this function can be called by an orchestrator. The other thing that's particular to our platform, we have this concept of bindings, which is if you want to code against an API, let's say Twilio to send text message, you can do that in very few lines of code. So you can see I don't use the Twilio SDK, I don't do authentication, any of that. All I do is put my secrets on my app or local settings, and this function, when it runs, will connect to Twilio before it starts executing, and once it's done, it's going to send the message out. So with very few lines of code. So that's all you would need to do some orchestration, kind of like what Direct One did. And they were able to prototype this solution when we did this hack fast that we sat with them for a few days. So super simple stuff that if you haven't tried orchestrator, I recommend. In the case of functions, called durable functions. What we learned from Direct One is we also have this product in Azure called Logic Apps. Allows for you to do an orchestration with a visual workflow. Real nice, drag and drop. You can do your conditionals, you can do your loops. Connects with 200 services. But in the case of Direct One, their developers, they want to control their orchestration in code. They want to do it in .NET, but you could do it in JavaScript as well. And 2 is their loops get really complex. Their logic is not as simple to represent on a logic app. So durable functions fit in really well for them. But you have the choice to pick which orchestration type is good for you. The other thing is interesting as we ventured into these orchestration things, and I know there are more talks later today that's going to talk about this topic as well, is a lot of folks could not go into serverless. It was a barrier to go into serverless because of state management or code that runs for a long time. So once you introduce this concept, a whole new set of scenarios got sort of unleashed or unblocked. In the past, if you want to do this, you probably would have to coordinate states using tons of queues. Your code will get really complex and hard to manage. One thing I recommend is the concepts. If you haven't seen, durable functions is built on top of the durable task framework. So if you haven't seen that before, there's some new concepts there, like the orchestrator, the activity triggers, and all that. But it's worth learning them. I think puts a lot of power in your hands as a developer. Last thing I have is, and these are just some cases, I ran through them pretty quickly. We have tons of them. But I want to give you sort of a variety of the problems that serverless is solving today. And just reiterate on the message that was also on the first keynote today, which is, it solves tons of scenarios. Try serverless first, but keep in mind, it's not a silver bullet. You might still have to use some things that are not serverless in your architecture. If you're new to serverless, there's a lot to learn. None of the talks here went to the very basics of serverless or how to get started. So I put probably 15 different links here on a single page on GitHub. So if you want to just learn serverless, I put tons of resources there last night. Azure Functions is open source. This product you've seen, Durable Functions, we went generally availability just 2 weeks ago at the Build conference. And we had 3 developers on the team that worked on it and 12 external contributors. So we're really proud of what we've done with open source and the contributions we took from the community. So if you want to use our products, go through GitHub, send a pull request if you're really adventurous and want to contribute to the product, but send an issue, bugs. That's how we interact with our customers a lot. Stack Overflow as well. The team competes to who has the most amount of stars on Stack Overflow, so they're really proud of responding any questions there. Otherwise, you can reach out on Twitter to us or anyone on the team. And that's all I had. Thank you.